Welcome students. In the previous class we actually discussed about electroscope, gold leaf electroscope, and also discuss about their applications and lightning. Okay. Today we are going to discuss about electricity at home. So at first we have to know about actually how we can use electricity at home. Okay, first of all, here you can see that first point is electricity at home. So generally electricity is transferred from main power station to smaller power grid and with the help of transformer. Okay, and here you can use actually in your home a electric meter and switch, main fuse, main meter, and also this is connected to a distribution board, and electric transmissions require special wires with good insulation. Now these are the actually we can say wiring. Okay, first of all we can here you can see that there are total three wires. First one is live, second one is neutral, and the third one is earthing. Okay, and all these wires are connected to main switch, and then actually after main switch we use in our home a meter. Okay, and from meter the total electricity is distributed in different devices or in different boards. Here you can see that in generally for actually identification, these three wires, that means first live wire, that is generally red or brown, okay, we take, and for neutral wire we take black or blue, and for earthing we just take as green or yellow. Now in generally live wire means actually live wire carries the total current from main to different appliances, okay, to the main switch, or we can say to the main fuse also. And the next wire, that is actually neutral wire carries current from away from the appliances to main, and hence the total circuit is completed, okay, by using two wire. One is live wire and another one is neutral wire. And earth wire is used for safety purpose only. Okay, this wire is connected to metal case of all appliances, okay, and to the earth. And in generally when some leakage current is actually happen, or some leakage current, we can found some leakage current through any devices or through any default, actually this type of leakage current is passed through earthing to the ground surface. Okay, here next point is actually the mains. Okay, here you can see that from the meter actually the current pass through main switch to main fuse, and from main switch current is carried to various electrical devices. That means actually first you can see one meter. This is, suppose you take meter, from this meter one main switch, this is main switch. After main switch you can see that from this main switch one main fuse, and after this actually some appliances, different devices, we can you can see electrical devices. So this is the general electric circuit or in the electric connection. Okay, here you can see also electrical connections are uses plugs, sockets, switches, okay, and also using different types of electrical devices. Now the question is, what is plug? In generally, all of you see the plug. Actually the plug usually consists of three pins, and here you can see that the two lower terminal pins are connected to live wire and neutral wire. So you can see that the left side, actually this one is actually live, you can see here, and the right side, this is actually neutral wire, and the topmost, actually the thicker top pin is earthing wire. So this is actually earthing pin, and it is connected to the earthing wire. And also nowadays you can also see a plug that consists of two pins. There is no earthing point, only one live wire and another one is actually neutral wire. Now you move to our next point, that is socket. Okay, here you can see that in generally a plug fits into a socket. Okay, that also has holes for the respective pins. That means if you take actually a plug that consists of three pins, then you have to use one socket that consists three holes. Okay, so these holes of sockets are connected to the main supply, and a socket has also three holes, two small holes for live wire and neutral wire, or live pin and neutral pin, and also one bigger hole that is actually earth connector, or that is for earthing connection. And if any type of leakage current occur, then it actually passes through actually earthing, and we actually save from getting electric source shocks. Okay, otherwise if earthing is not happening, then we get shock, electric shock. Now we move our next one, that is switch. Switch is a very small device that is used to close or open a circuit. Okay, it is always connected to live wire. That means here, if suppose this is your meter, then after meter you just use one, actually you can use here, after meter you can use like fuse. Okay, then you can use switch, and after switch you can use appliances or device, electrical devices. And here we move to our next one, that is switch. Switch means actually it is cover, it is in the front cover of a switch is made of insulated substance such as bakelite, ebonite, etc., and the inner side is conducting material such as that brass, copper. Okay, when the switch is on mode, then you can actually the current flow through this circuit. If switch is off mode, that means no current flow through this circuit. That means this is how actually a switch helps in making or breaking a circuit. So if switch is on, then current is passed through the circuit, we get a closed circuit. That means actually making a circuit. And if switch is open, that means current is open, or we can say circuit is open. That means this breaks, actually this breaks a circuit. Okay, now we move our next one, that is electric meter. So in generally, electric meter is used for consumption or for recording the consumption of electrical energy. Okay, it is generally measured by kilowatt hour. That means 1 kilowatt hour is equal to 1 unit. Also it is known as 1 BOT unit, that means board of trade unit. Okay, In generally kilowatt means you can say here, you can say kilowatt, that means if you take kilowatt, it is actually power, and hour, this means actually time. So power into time. Power means actually energy or work done by time, we can say, and into time, that means this is energy. So easily you can say that kilowatt hour is a unit of actually energy. Now the question is, in generally we can say that SI unit of energy is joule. So you have to convert 1 kilowatt hour into joule. So what is the value? So that means actually 1 kilowatt hour is equal to, we can say, 1 kilowatt into 1 hour. 1 kilowatt means actually 1000 watt into hour means 3600 second. And also you can say 1000 watt means joule per second into 3600 second. So second got cancelled and you get answer 360000 joule, or you can say that actually 3.6 into 10 to the power 6 joule. So this is the answer. Okay, that means the answer is 3.6 into 10 to the power 6 joule. This is 1 BOT, or you can say 1 kilowatt hour. Now we move our next topic. Okay, before going to next topic, you can see these are the actually some electrical appliances and their power. That means LED bulb, you can say this is 5 watt, 8 watt, or nowadays actually we can get different types of 23 watt, 15 watt also. Okay, in generally fan means 40 watt. Okay, tube light also 40 watt, electric bulbs maybe 60, 100. Okay, television means 100 watt, refrigerator 380 watt, iron 1 kilowatt approximately, and air conditioner also 1 kilowatt approximately. Now here you can see, if you know actually the power in kilowatt hour and the time that is in unit hour, then just by actually product with power with time you can get unit. Okay, or how much energy is consumed for a day or for a month. And also if you know the electric cost, or what is the amount or what is the cost for 1 unit electricity, then you can easily find out electric bill also. Okay, suppose we take an example now. Okay, suppose I take one devices, a fan that is suppose 40 watt. Okay, and it runs for two suppose 10 hours, 10 hours per day. So you can say per day, that means actually you can say for 1 day total energy is equal to 40 watt means 40 divided by 1000 kilowatt into hour, that is 10. Okay, so this is for per day. That means you can say that 4 by 10, that means zero point 0.4 kilowatt hour, or zero point 0.4 unit electric energy consumed by this device per day. So if you get for 1 month, suppose you take actually 1 month is equal to 30 day, then total energy is equal to zero point 0.4 into 30. Okay, that means actually you get energy is equal to 12 unit, okay, for 1 month. Now if actually electric cost for per unit, if rupees 8 per unit, then total actually bill is 8 into 12 rupees, okay, so that means 96 rupees for 1 month, okay, for this device. So first of all you have to find out what is the total energy consumed per day, then per month, then you have to product with cost. So this is the numerical types you can share. Okay, now we move to our next topic, that is electrical hazards. Okay, in generally electricity, that means actually flow of energy, electric energy, okay, must be used actually very carefully and also very with very safety. Otherwise actually we can face problem. That means actually if inappropriate use or negligence in care and maintenance of electrical wiring and appliances can causes hazards, okay, that may even turn out to be fatal. Though, so first of all actually we just discuss some electrical hazards. First point is air overloading, okay. In generally all electrical circuits have a certain amount of capacity to draw current, but if we use too many devices to same circuit, to one circuit, then actually for particular circuit larger amount of current is passed through one wire, okay. So in this case actually the wires draw a much larger current from the mains than they can handle. This is called actually overloading, okay. For this overloading case actually this causes heating in the circuit that can lead to sparking and electrical fires also sometimes, okay. And what is short circuit? Actually due to defective or loose connection or damaged wiring, okay. Sometimes actually live and neutral wire may connect it, okay, sometimes may touches. So that is why actually for this case actually some in a certain way large amount of current is passed through this circuit. This is called short circuit. And for short circuit we can actually see that huge amount of current is passed through some devices, electrical devices, that means sound system, bulb, mixture, grinder, television, AC, etc. So for this case these devices may get fire, okay, or may actually fault, okay, we can get a fault. Now the next one is electric shock. Okay. Due to negligence, if a person touches an exposed live wire, okay, in a circuit, then he will obviously receive a shock. And electric shock can often be fatal. Okay. So these are the electrical hazards also. Now which type of actually safety precautions or safety devices we have to use in electrical connection, okay. So first one is you have to use electrical fuses, okay, or electrical fuse. In generally for it is used for safety purpose, and if we actually want to overcome overload due to large withdrawal of current or some fluctuations for such same circuit, we just use electrical fuse, okay, before and electrical devices, okay. This contains actually thin wire, that is a alloy, that means 60% copper and 40% lead, okay. Its melting point is slightly below the melting point of connecting wire in generally, okay. So less than melting point of a fuse wire is less than melting point of any connecting wires. And also you can say that, okay, the resistivity of the wire fuse wire is high, and we just use here you can see that for fuse wire this is actually copper clamp, this is live wire, this is neutral wire, and also this wire is actually fuse wire. And here you can use porcelain grip. Okay, so we just use in series combination or series circuit electrical fuse to avoid actually or to resist some types of electrical hazards, that means overload, okay, fluctuation of current, short circuit, okay, etc. Now we move our next devices that is used, that is MCB, okay, miniature circuit breaker. So actually replacing a fuse wire in time consuming, and for this case actually we just use MCB. Okay, this is also connected in series with live wire. Okay, and for this case, and this is if switched on, here you can see that one switch is occur. Okay, that means if switch is on, then actually current is passed through live wire. Okay, if sometimes if danger happens, that means if circuit gets overloaded, then actually it automatically goes down and the circuit gets break. Okay, so this is the working principle of MCB. And what is earthing? Actually, earthing means it is very important part, or it has important role in our electrical connection. Okay, in generally some electrical devices that is used in our home, that is made of metal. Okay, and all metal bodies of various devices such as iron, kettles, refrigerator, and etc. they are connected to earth wire, and for this case, one end of the wire is connected to all the body, that is made of different metals, and other end is connected to earth. Okay, through one metal plate. So sometimes if any type of actually leakage of current occurs from any devices, then this type of undesired current is reached from outer body to earth. Okay, so in this case we do not get any type of electrical shock. So this is the actually principle of earthing. Now we move our next point, that is battery. In generally we just we can see that in our uh, home some devices actually, for some devices we just use electrical current, okay, but for some devices, that means wall clock, cell phones, remote controls, these are the electrical devices without connecting any type of plug switch, they can easily actually run. That means they actually some energy actually they are getting from some devices. That device is called actually battery. Okay, so battery is a source of electricity. It provides electrical energy, and also here chemical energy convert into electrical energy. And battery means actually a collection of electric cells, okay, that is connected in series. If you take a dry cell of 1.5 volt or 2 volt, then you can say a battery of 6 volt means actually if you take 1.5, then 6 volt battery means 4 dry cells actually connected in series combination. Now we move our next one, that is actually dangers of electricity. Okay, so in generally, even though electricity lights up our homes and etc., we just uses different types of electrical devices with the help of electricity, but we have to actually handle very proper way in this in very proper way or properly, otherwise we face different types of problems. Okay, so always actually we have to maintain some precautions actually during use the electricity. So first one is we can say that do not touch any type of switch with wet hands. Okay, because water is the actually a conductor of electricity. Second was connecting wires, plug, switch, socket should be fitted tightly. Okay, third one is all electrical devices should be earthed. The fourth, ensure that fuse and MCB uses in the circuit are correct strength also. Okay, and the fifth one, tools used for electrical work and maintenance must have proper insulated handles also, not conducting. The second next one is always wear rubber gloves or rubber footwear while working with electrical devices. Next one is the main should be put off while working on the main board or main cable wiring or installing a new devices. The next one is the household wiring should be done by using good quality wires, having proper thickness and insulation also. And the last one is actually defective switches, sockets or wires should be replaced immediately. So these are the precautions when we just dealing with electricity. So actually in this chapter we just discuss actually first static electricity, different types of actually difference between static and current electricity, and also we know about different charging method, that means charging by friction, charging by conduction and also charging by induction. Next, we just discuss a device that is electroscope. It is used generally for actually special type of electroscope, that means gold leaf electroscope. It is generally used to detect presence of charge and also to detect nature of charge also. And then we just use for current electricity at homes. Okay, which components we generally use: plug, socket, switch and also meter, battery, etc. And some safety precautions. Okay, that means for safety purpose we use fuse, MCB, earthing wire, etc. And also you have to know what are the precautions that is generally taken during actually dealings with electricity. So this is the end of today's class. In the next class we discuss about actually the exercise problem of electricity. Okay, thank you.